Hello, it's Mr. LaBeouf again, and today we're going to go shopping. And on our little shopping spree, we have a $10 bill. And we're going to buy some items that total $6.89, including any tax. We hand the $10 bill to the cashier, and we should know what is the change we're going to get exactly. This video is about that, finding change from a $10 bill. Once we learn how to do that, it'll be an easy transition to a $5 bill, $20, $50, $100 bill. And here's the key. When we have a $10 bill, we have to think of $9 plus $1. I hope everyone will agree with me that $9 plus $1 equals $10. That's pretty straightforward so far. Now, if you spend $6.89 and you're paying with a $10 bill, you are not going to get $4 back, right? The change you get back has to be able to add to the $6.89 to get 10. 4 would be too much. $4 plus $6.89 is $10.89. You only handed over $10. So you're going to get $3 and something. And this is where the $9 comes in. The $3 change that you get when you add to the $6 of the price is $9. Well, now we have to get these two numbers, what we paid and the change, to add up to $10. The $3 and the $6 is $9. We need another dollar. How do we get that? Well, this is 89 cents. How many cents do you add to 89 cents to get $1? There are 100 cents in a dollar. So we need, of course, 11 more cents. So right here, when we look at the pennies, the 89 cents plus the 11 cents is 100 cents, or the other $1. So it is $9 from 6 and 3 plus another $1 from the 100 pennies. That's how it works. We're going to break it down, though. We're going to talk a little bit about why do the 89 and the 11 add up to 100? So let's break it down. One of the most important things to realize about mathematics is that it is incremental. It works in increments or little steps. In order to be able to work out a problem you might encounter in third grade, you have to have mastered certain skills and concepts from first and second grade. So we're going to talk about the building block step for finding change from a bill, like a $10 bill. And the building block step we need is, given a two-digit number, what do you add to it to get 100? Numbers that add to 100, whole numbers that add to 100. I'd like to suggest that if you're not already there, you need to very soon get to the point where if I say 13, the number 87 immediately pops into your head. Under many circumstances, that'll be valuable. 13 plus 87 is 100. It's valuable for finding change from a bill. Now, why does 13 plus 87 equal 100? And one of the things I should say about this activity, this knowledge-building video about finding change from a dollar, is I want everything to be done mentally. It should be able to be done mentally because of the understanding you have of the number system. In other words, it is true that you could go like this, take 13 plus 87 with the standard addition algorithm. 3 plus 7 is 10, put down the 0, carry the 1. 1 plus 8 is 10, and we get the 100. But you shouldn't have to do that. Are you memorizing that 13 plus 87 is 100? Well, I guess in one sense that you are. But if you practice with several of them repeatedly over a period of time, you're going to get to the point where you've kind of memorized them, but you may not even realize that you have. Given any two-digit whole number, or even a one-digit whole number, given any whole number less than 100, you should instantly be able to tell what adds with that number to make 100. And that is based on 90 plus 10. I hope we can all agree that 90 plus 10 is 100. Another way to think of this is 9 tens plus 1 10 is 10 tens, right? 9 tens, the 9 is in the tens place, this 1 is in the tens place. 9 tens plus 1 10 is 10 tens. Now, we can't put 2 digits in the tens place, so it becomes the 3-digit number 100. So let's go back to that 13 plus 87, and let's find the 90 plus 10. Where's the 90? Well, right there. 110 plus 8 tens is 9 tens, or 90. So we need another 10. We need one more 10. And we, of course, find it with 3 plus 7. Okay? With 13 and 87, you have 9 tens, 110 plus 8 tens, for 9 tens are 90, and then 3 plus 7 is 10, and 90 plus 10 is 100. Okay? Now, I guess even a more basic skill of, adding two whole numbers to 100 is realizing that 3 plus 7 is 10. That's important to know, but you no doubt mastered that in first or second grade. In order to show all of them, I would have had to done 50. I think just 50. From 1 plus 99, 2 plus 98, 3 plus 97. I started with those. And then I think I'd have to go all the way up to 50 plus 50. I wouldn't have to go any further because addition is commutative and we would just get the same facts in reverse order. I didn't want to do all 50, so I'm just giving you a flavor here. Of course, 1 plus 99 is 100. Now I wrote 1 here in kind of a strange way with a 0 in the tens place, just to emphasize that there's the 90. We've already got the 90 here, we got no tens here, and then 1 plus 9 is 10. So we've got 90 plus 10. And the same here, we've got 90 right here, so no tens here, and then 2 plus 8 is 10. 90 plus 10 is 100. 90 plus 10, 3 plus 7. Ordinarily, of course, we don't write the zeros here, but I think it might help to see how things work. Now, once we get to a number like 11, 11 plus 89 is 100 because we've got 110 plus 8 tens is 9 tens or 90, and then 1 plus 9 is 10, so there's our other 10. All of these two whole numbers that add up to 100 are based on 90 plus 10. 22. Let's just skip around. You can look at some of these that are up here, and this is just a sampling. Let's look at 22 plus 78. Why is 22 plus 78 100? Well, we've got 20 plus 70. 2 plus 7 is 9, but those are in the tens place. So it's 20 plus 70, 90 plus 10. 90 plus 10 is 100. They all work that way. So I'm not going to go through all of them, but you should practice and get to the point where if anyone is to give you a whole number less than 100, you can instantly come up with the other number that adds with it to get 100. When I'm going over with students finding change from a bill mentally, I usually don't use something like 30 cents or 70 cents because it's too easy, but I don't want to totally neglect these numbers. Obviously, 30 plus 70 is 100. You don't really see the 90 plus 10 here because what you have is 3 tens plus 7 tens is 10 tens. And how do we write 10 tens? 10 tens is 100. So there it is. We don't have to go to the ones place. And of course, 80 plus 20 is 100 because you've got 8 tens plus 2 tens is 10 tens, right? We've got 10 tens, 10 tens, and the way we write 10 tens is 100. Right? There's the 10. It can't go in the tens place. You cannot put 2 digits in the tens place, so you go to the third digit and we call it 100. We won't be using 30 cents or 20 cents or 80 cents in our change problems because they're too easy. All right, ladies and gentlemen, you have spent $5.07 and you hand to the cashier a $10 bill. What is your change? You're not going to get $5 back because you spent more than $5. If you were to think about putting a $5 here, it's immediately too much because $5.07 plus $5 is $10.07. This is too big. So you should immediately recognize because there were some cents, you're only going to get $4 and some cents back. So we can put a 4 here. Hopefully be pretty confident about that. $4. If you're not going to get $5 back, you're going to get less than $5, so it's going to be 4 and something. So again, as I said before, change from a $10 bill is all about $9 plus $1. The $5 you've spent plus the $4 that you will get in change, those add up to $9. And by the way, this is what you spend, and this over here is your change, and we're working with a $10 bill. So now the question becomes, we need another dollar. We need $9 plus $1 to equal the $10. You see, the $10, we just think of it as being broken down into two parts of what you spend and what your change is. The two add up to $10. And because this has some sense here, now obviously if it were $5, if you spent exactly $5 and gave a $10 bill, you'd get $5 back. That's too easy. So we need that other dollar, okay? And we spent 7 cents. So the change we get back has to add with 7 cents to make 100 cents or a dollar. What do you add to 7 to make 100? Because there are 100 cents in a dollar. So it's 93 cents. 7 cents plus 93 cents is 100 cents or $1. So there it is. There's the change, $4.93. Now, I want all of these to be done mentally, but we should make a connection with the standard addition algorithm for money. How do we add money on paper? Well, we could take the $5.07 plus the $4.93 and add them together. You shouldn't have to do this, but we can add them together. 7 and 3 is 10, put down the 0, carry the 1. 1 plus 0 plus 9 is 10. Put down the 0, carry the 1. 1 plus 5 plus 4 is 10. We have to go like this, putting a 0 in the 1's place and the 1 over here for the 10's place. The decimal point comes straight down. When we're adding or subtracting decimal numbers, that decimal point comes straight down into the answer. And there's the check on paper, which we shouldn't have to do. But there it is, in case you were wondering. And something else in terms of fractions, this 7 cents here is really 7 hundredths. This decimal number, 0.07, is 7 over 100. Because you've got 2 digits to the right of the decimal point, so you have two zeros in the denominator. That's how decimals work. This 93 cents over here is really a fraction. We don't write money in fraction form. We use those decimals, but decimals really are fractions. 93 cents or 0.93. We've got 2 digits to the right of the decimal point, so we need 2 zeros in the denominator and 9 and 3 in the numerator. Now, if we add these two fractions, of course, we have that denominator of 100, which doesn't change when we add. So the denominator is 100. And we add 7 plus 93 to get 100. 7 plus 93 is 100. And there's a fraction, 100 over 100. Well, you should know by now that that's 1. In this case, it would be $1. Okay? If we were just adding these decimal numbers, see, I just added the fractions there. and got 100 over 100, which is 1. If we were to add these in decimal form, we kind of already did it over here, but 7 plus 3 is 10. Put down the 0, carry the 1. 1 plus 0 plus 9 is 10. But we cannot put two digits in one place, so we have to put a 0, carry a 1 over into the ones place. That just adds to 0 here, and we get 1, and we bring that decimal point straight down, and there's the 1 written as 1.00, and it kind of looks like a dollar when we do that. Let's close with 7 more. I've tried to show a variety using different digits, and the first one we'll look at is $5.91. Over here on the left side, that's what you spend. In the blank, we're going to fill in your change, and the two have to add up to $10. And notice that none of these are whole dollars. That would be too easy. And as I said before, there are no zeros in the pennies or hundredths place, because those are kind of easy too. This is as hard as it gets in finding change from a $10 bill. It does not get any harder than these. $5.91. You're not going to get back $5. You spent more than $5. So you're going to get back 4 and change. 9 plus 1 is 100. That's how, I'm sorry, 9 plus 1 is 10, not 100. That's how these are going to work. So we have to get $9 when we add with the $5, we have to get $9. So that's why we have 4 here. We need another dollar. How are we going to get the other dollar? Well, we've got 91 cents here, so we need 9 more cents, right? 91 cents plus 9 cents is $1, and then the $5 plus $4 is $9. $9 plus $1 is $10. That's how all of these work. $7.63. What do you add to $7 to get $9? You get up to $9. So, $2, right? 7 and 2 is $9. We need another dollar. We've got 63 cents. What do you add to 63 to get 100? 37? At some point, we'll do some of this in class, a little bit. Practice this. Given one whole number, less than 100, what can we add to it to get exactly 100? And in this case, it's 37, right? 60 plus 30 is 90 cents, and 3 plus 7 is 10 cents. 90 cents, 10 cents is $1, okay? So here again, we have the $9 plus $1. $9 with those two, and 63 cents plus 37 cents is 100 cents or the other dollar. $6.38. You're not going to get back $4. You're going to get back 3 and change. $6 plus $3 is $9. You now need an amount of cents to add to 38 cents to get 100 cents. What do you add to 38 cents to get 100 cents? It's 62 cents, right? 62 cents. All right, let's break this one down. $6 plus $3 is $9. And then the cents. 38 plus 62. This is that more basic skill. Do you know immediately that the number you add to 38 to make 100 is 62? Well, let's try to get to that point. Let me just quickly show it here. 38 plus 62. Well, 30 plus 60 is 90, and 8 plus 2 is 10, and 90 plus 10 is the 100 cents, which is $1. That's how those work. $2.19, $7. We'll add to the $2 to make $9, and then we need another dollar. We've got 19 cents, 81 cents. 19 plus 81 is 100 cents, which is $1, plus the 9 is $10. $9.57. Okay. Well, you're not going to get back any paper money at all, are you? You're not going to get back $1 if you spent $9.57 and you pay with a $10 bill. Well, we could put a 0 in the ones place, in the dollars place. 0 plus 9, there's the $9. So now we just need the cents that will add to 57 cents to make 100 cents, which is one more dollar. What do you add to 57 to get 100? It's 43, right? These two add up to 100 cents, 100 hundredths of a dollar, which is $1. 50 plus 40 is 90 cents. 7 plus 3 is 10 cents. 90 cents and 10 cents is 100 cents or a dollar. Plus the $9 gives you 10. Oh, this is sort of the reverse situation. You only spent 45 cents and you pay with a $10 bill. You're going to get back $9 plus some cents, right? You got $0 here, so you're going to get back $9. We need another dollar. Well, you spent 45 cents. What do you add to 45 to get 100? 55, right? So there's $9 plus $0 is $9. 45 cents plus 55 cents is the other dollar. $9 plus $1 is $10. Right? Why does 45 plus 55 equal 100? And it's really 100 hundredths, or 100 cents, right? 4 plus 5 is 9, or 90, and this 5 plus 5 is 10. 4 plus 5, 40 plus 50, 90. 5 plus 5, 10. 90 plus 10 is 100. 100 cents. All right. $3.22. I hope you're getting the sense. No pun intended. We've got, this is, pennies, 100 cents and a dollar. And then I just also use this word here. I hope you're getting the sense, S-E-N-S-E. That's like to get a sense of something is to understand it. I hope you're getting the sense that none of these is really harder than the others. You should get to the point soon where you feel that they're all easy. $3.22 you spent. You are not going to get back $7. The store would be losing money that way, right? Because these two amounts are adding to $10. If you try to put a $7 there, well, you're instantly already above $10. $3.22 plus $7 is $10.22, but you only gave the cashier $10, so that doesn't work, right? $6. You'll get back $6 plus some coins. Why $6? Because the way I've asked you to look at this, they make $9. $9 plus $1 is $10. So we've got the $9 here with the 3 and the 6. So now we need some cents that will add with 22 cents to make 100 cents. What do you add to 22 to make 100? Well, again, it's not 80, right? This starts with a 2. This is 20-something. But if you add 80 to 22, you're more than 100. So it's 70-something. In fact, it's 78, right? 22 plus 78 is 100. 100 cents is $1, plus the 3 and 6, or $9, gives you the $10. Now, I know I went through this kind of quickly. Each of you will have to pace yourselves between watching this video and the instruction in class, the practice that we have in class. And very soon, I would like everybody to get to the point where anytime you walk up to a cashier at a store and you hand a bill, you should know before you hand the bill over what your change is going to be. And it's not a difficult step. Keep working at it till you get it. If you run into trouble, let me know. Practice will bring you there. Thanks for listening. We'll see you soon.